Here is some mixed review to tackle after watching the product quotient and chain. So see if you can get some of these on your own, pause the video, and then check the answers. So for this first one, we have 6 to the x plus x squared divided by ln of x minus 3x. So definitely going to be a quotient rule. That one is easy for me to recognize, but one of the harder rules to do. So I can recognize it because I have x's in both the top and the bottom. I'm going to do the derivative of the top, the original bottom, minus the derivative of the bottom times the original top, all over the original denominator gets squared. So lots to fill out here. First of all, the derivative of the top. Derivative of 6 to the x is ln of 6 times 6 to the x. Plus the derivative of x squared is 2x. So we did the derivative of the top. Now we need to do the original bottom, ln of x minus 3x. Now I need to take the derivative of that bottom. So derivative of the natural log of x is 1 over x. Derivative of negative 3x is negative 3. So we did the derivative of the top, the original bottom, minus the derivative of the bottom gets multiplied with the original top, 6 to the x plus x squared, all over the original bottom gets squared, ln of x minus 3x. So we did our quotient rule. As I check it over, derivative of the top looks good. Original bottom is copied down correctly. Minus, we did the derivative of the bottom times the original top, all over the original bottom squared. All right, so the next one, we have 5 times the natural log of x. So we have some product here, because it's multiplied. Is it a product rule though? So a product rule is x's times x's. This is just 5 times the natural log of x. So keep in mind, not a product rule, what that would look like. So we had lots of not product rules, like if it's just 5x or 5 times e to the x. So things that are multiplied 5 times x, the derivative is just 5, right? Derivative of 5x is 5. Same thing with this. We kept the 5. We said the derivative of e to the x is e to the x. So there are things that are not product rules that are still multiplied. This is one of them. We have 5 times the natural log of x. We're just going to keep the 5 and take the derivative of the natural log of x to be 1 over x. So this is not a product rule. But the one below it is. We have 5x times the natural log of x. We have a first factor and a second factor, both with x's in them. So now this one is a product rule. It's not like having 5x cubed where you just bring down the power, subtract from the new power, and keep that 5. We have 5x times ln of x, 2x terms. So I'm going to use the product rule. I'm going to do derivative of the first, original second, plus derivative of the second times the original first. So derivative of the first times the original second. Derivative of 5x is just 5. The original second is the natural log of x. Product is plus. Now I'm going to do the derivative of the second times the original first. Derivative of the second factor, derivative of the natural log of x is 1 over x times the original first is 5x. So we had a quotient, a basic derivative, and now a product. And let's look at this next one. So we have the 7th root of 7x minus 3 to the x. Is this a basic derivative or is this one of our longer rules? Well, we have to first rewrite this. 7th root is really 7x minus 3 to the x raised to the 1/7. First power, because there's not like a big power in here. If there was a big 4 in here, I'd say it's the 4/7, but it's not. So just the first power, 7th root. Now that we see it like this, we have more than just x raised to a power. So that is going to be a chain rule. So we're going to bring down that power, 1/7, and subtract 1 for the new power. So 1/7 minus 1 is going to be minusing 7/7. Keep the same denominator, and we get negative 6/7. We do 1 minus 7. That original inside is what's getting raised to the new power here. And the last part of chain rule, bring down the power, subtract from the new power, multiply by the derivative of the inside. So the derivative of 7x is 7. And now I need to do minus the derivative of 3 to the x. Keep in mind that's not negative 3 to the x because you only raise positive numbers to the x. So you have minus, and then derivative of 3 to the x is ln of 3 times 3 to the x. Okay. Last one here, some good practice spotting which rule is which. See if you can figure out which one this is. First thing I notice is there's only x's in the bottom. So I'm going to just rewrite this. This is not a quotient rule. So I'm going to keep that 2. And it's x to the 6 minus e to the x. It's just raised to a negative 8 power. If you don't have x's in both the top and the bottom, you do not have to use the quotient rule. So I'm going to just bring down this power. 2 times negative 8 is negative 16. Subtract 1 for the new power. Negative 8 minus 1 is negative 9. Copy down this original inside. And last part of chain rule, multiply by the derivative of the inside. Derivative of x to the 6 is 6x to the 5th. And then we had minus, derivative of e to the x is e to the x. So 2 chain rules at the end there. They just look so different, but the chain rule is at least a shorter one to have to do. And the more that you practice these, the easier it will be to recognize which rule is which, whether you have a quotient, a basic, a product, or a chain.